So we've learned about molar mass in the mole and some simple calculations with the mole. Let's go ahead and put some more of this to practice. First up, what is the molar mass of zinc chloride? ZnCl2 is the formula for zinc chloride. So I need to look at the periodic table and I need to see the information that I need, which would be the atomic weight listed for these elements. You should always have a periodic table with you when you're studying, but if you're ever like on your iPad or your computer and you just don't have a paper periodic table with you, a great website I truly really like is ptable.com. It stands for periodictable.com. I really, really like that website. It's got a lot more, it's got the periodic table, yes, but each element listed has a lot more information on it. You can click on individual elements and learn more about it, different properties they have, etc., that we'll be using throughout the course, throughout this course and the next. So in zinc chloride, I have one zinc. I look it up and I see that zinc has a molar mass of 63.55 grams per mole. So again, that means if I had exactly 1 mole of zinc atoms, so 6.022 times 10 to the 23rd zinc atoms, it would weigh 63.55 grams. Notice in the formula I have two chlorines, so I need to make sure to multiply that mass by 2 to account for the two chlorines. Chlorine has a molar mass of 35.45 grams per mole. Zinc gives me 63.55 grams per mole. The chlorine giving me 70. Now, if I put this in my calculator, it just says 70.9. But notice I have 4 sig figs here, so I need 4 sig figs here as well. So I need to put a 0 there for my sig figs, grams per mole. And then I add these two numbers up together to get the total molar mass. And when I add this up together, I see that my final answer needs to be precise to the second decimal place. So I get 136.29 grams per mole. So I actually started with 4 sig figs and ended with 5 because of the rules on addition subtraction, in this case addition for sig figs. Next up, what is the molar mass of H2O? Well, that is just water, but let's go ahead and add some molar mass anyway. Here I have two hydrogens, and when I look at the table, I see that each hydrogen has an atomic weight or a molar mass of 1.008. So what that means is that 1.00 grams of hydrogen is exactly 1 mole of hydrogen. I have two hydrogens in this formula, so I need 2 of this. That gives me 2.016 grams per mole for just hydrogen contributing to this compound. I also have one oxygen. Oxygen is 16.00 grams per mole. So overall 16.00 grams per mole. Because again, I want 4 sig figs on my molar masses. I add this up and calculated gives me 18.016 grams per mole. But again, I'm following addition rules here. And although this is precise to the third decimal place, this is only precise to the second. So I need this precise to the second as well. So I'm going to report this as 18.02 grams per mole. Let's look at our next one. What is the molar mass of magnesium phosphate? Mg3PO42. So remember what these little subscripts mean. This means I have 3 magnesiums in this formula. This 2 means I have 2 of this entire thing. So I have 2 phosphates. I don't care about the charges. Those are canceling out with the magnesium because magnesium with +2 charge here. We'll talk about that separately in this chapter when we learn about naming and such. But what that means is that I have 2 of my phosphorus, and I have 2 times 4. I have 8 of my oxygens. So 3 magnesium. I look up magnesium on the table and I see it has an atomic weight of 24.31, which means its molar mass is 24.31 grams per mole. When I multiply that out, I get 72.93 grams per mole for just the magnesiums. My phosphorus, I have 2 of them. Phosphorus on the periodic table tells me 30.97. So that means that 1 mole of phosphorus atoms weighs 30.97 grams. Multiplying that by 2 gives me 61.94 grams per mole. And 8 oxygens. 8 times 16.00 grams per mole. When I multiply that out, it's going to tell me 128. But again, this is precise to the 4th sig fig because zeros after decimals, after integers are significant. So I need 4 sig figs here as well. So I'm going to go ahead and write a 0.0 here. When I add these numbers up, keeping track of the fact that I have to stay to this number of decimal places, I can only keep to the first decimal place because of my limits of sig figs, not with addition. I get a molar mass of 262.9 grams per mole. Okay, let's do some simple conversions with moles. How many moles are present in 9.25 times 10 to the 24th molecules of C3H8? Remember that 1 mole is equal to 6.022 times 10 to the 23rd of whatever that species is, whatever I'm looking at, okay? So if I have 1 mole of something, I have 6.022 times 10 to the 23rd of that thing. A mole is the SI unit for number of entities, number of things I have. It's like if I say I have a dozen of something, I have 12. If I have a mole of something, I have 6.022 times 10 to the 23rd of that thing. Excuse me. I apologize. So write down what you're trying to find. You're trying to find number of moles. Write down what you're starting with. 9.25 times 10 to the 24th molecules of C3H8. I'm trying to get to moles. I'm trying to cancel out molecules. So, because my molecule's in the numerator here, it needs to go in the denominator here. That's how it's going to cancel numerator to denominator. This leaves this in the numerator, which is what I want. If I put it opposite, if I put this in the numerator, my units would have come out molecules cubed over moles, and that's not correct. So 1 mole of C3H8 contains 6.022 times 10 to the 23rd molecules. When I plug that in my calculator, this is one of those numbers where it's hard for me to gauge like what's realistic. I know it'll be bigger than 1 mole because 10 to the 24th is bigger than 10 to the 23rd. But those numbers are so large that it's just hard to correlate it. So make sure you're trusting, make sure you've practiced enough times in your calculator, you know how to use it properly. You should get out 15.4 moles of C3H8. So make sure you're actually practicing these things in your calculator, getting the same answers as me so that we know you're using your calculator correctly, okay? This has 3 sig figs. This has 4 sig figs. My final answer has 3 sig figs. And our last example in this section, a certain gas canister contains 4.82 times 10 to the 18th gas molecules. How many moles of molecules of gas are present? So, what are you trying to find? Number of moles of molecules. So very similar to the last example. Write down what you're starting with. 4.82, 10 to the 18 gas molecules. Again, I'm trying to get to moles. I'm trying to get away from gas molecules. 1 mole of gas molecules contains 6.022 times 10 to the 23rd of that molecule. My gas molecules have canceled out and I'm getting moles of gas molecules left over. When I plug this in my calculator, I get out 8.00 times 10 to the minus 6th moles of gas molecules. And when the numbers are that big, it's hard for me to really be like, oh yeah, it's realistic. I know that it'll be less than a mole because I have less than 10 to the 23rd molecules. So being less than a mole is correct. Otherwise, I have to practice enough in my calculator so that I know I'm using it correctly. 3 sig figs, 4 sig figs, and 3 sig figs.